Hello everyone, it's March 28th. We're getting closer to the end of March. It's a Sunday. I just finished cleaning. I need to rest my legs, so let's do this. We have no notification. Let's see what we have. Reconstruct original digits from what? From English. Wait, what the hell is this? Given a non-empty string containing an out-of-order English representation, okay? Output the digits in ascending. Who came up with this stuff? Who came up with this? So this is an English word, but it's out of order. How do I even know it's 0, 0, 12, 0, 1, 2, 5, 4. Oh my dear Lord. So we have to deconstruct this first. Is that what it means? Alright, input contains only lowercase English letters. That's good. It's guaranteed to be valid and it can be transformed to its original version. That means invalid inputs are not permitted. Okay? Input length is less than 50,000. Alright, but hold on. Hold on. How do I know the outputting ascending order? My bad, didn't see that. Okay, so output. So basically, it's just 0 to 9. It's scrambled, so we need to descramble it. Huh? So I could. I mean, from the input, from the words to the letters, to the numbers. This I think is pretty trivial. What is not trivial is decode this thing, right? So it feels like you're trying to decode a secret message. Well, I think this is yet another time that the first thing come to my mind is counter. So basically we need to know the frequency of this, right? We can write out from 0 to 9. For example, if Z exists, that must be a 0. Things like that. So we do some analysis on this. So I'm writing out right now, actually, to make it more friendly to us. I'm just gonna do it. Let's do it in one of my text editors, so I can take a look. So what we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so this one is unique. This one's good. We already did it. So if we have 0, right? If we have, not 0, if we have Z, that means we have 0. Alright, so this one's done. O, N, E. I will have two of O, too many O's. How about N? I have one N. No N. Well, 2 has N. 1 and 7 has N. Okay. E. Well, the tons have E. Oh, 6. 6 is done. Alright, 6. Right. If we have X, that means we have 6. Right? 0. So 0, 6 is done. Which mean they also mean if we don't have X, that means there's no 6, and we don't have Z, that means we don't have 0. Which means we can solve 7 as well, right? Because 7 is the only one that has S in it. So we can come in here. We say if there after removing all 6's, if we have S, that means we have 7. So every time when I say we have it, that means also we're removing it. We're removing these letters. It's from a counter, right? We're removing the count from the letter. So we've done all these, and we also removing. So they're gonna be no R, We still have 2 R's. No E. We have E. No I. We have 3 I's. No S. S is already unique. No X. No, not working. No V. Here we go. V. 5 is the only one that has V. So 5, we say after removing all 7s, if we have V, that means we have 5. Okay. What's next? 5 would take away the F. Good, now it's 4. Right? So we say after removing all 5s, if we have F, that means we have 4. What's next? So we're removing U, removing R. The only thing that has R left is this thing. So now we can handle 3. Yeah, we can handle 3. So after removing all 3s, no, all 4s, if we have R, that means we have 3. Okay, we're almost there. What's the next? So 3 removing E. We still have lots of E. H. H. We're removing H, so it's going to be 8. So after removing all 3s, if we have H, that means we have 8. Okay, so we still have E, I. There's no more I, so 9 can be gone. After removing all 8s, if we have I, that means we have 9. The last 2, W. W actually can go first. Yeah, W can go first. I just realized. This 2 is the only one with W. And W can go first. W actually could be... Oh, what did you do, man? 2 can go first. I'm on the first, right? If we have W, that means we have 2. And then the remaining is 1. Okay, so we have a strategy. We have a strategy. So how do we translate this into code? Let me think. We're gonna do, definitely gonna copy it first. Counter. Yeah, we're gonna do counter. That's for sure. And with counter, we're gonna start from the unique ones and just go one by one. Let me think. So we're gonna say result. No, we're gonna say result list. We're gonna put in a list first. We're gonna sort them, and we need counter from collections. Import counter, right? So into counter, and we're gonna say counter is counter S, right? And then we're going to use this. I'm actually going to put this into the remaining is 1s. Alright, so this is going to be inside our wait, I didn't do it this way, right? So we're going to say the logic. Boom. Right there. Reformat it. Okay, so that is the logic. Okay. So what do? We're going to check for Z, right? So it's not going to be a loop, right? It's not going to be a loop. It's just going to be a lot of if else statement. We'll just say if Z is in, let me first check if this counter thing works. think it does. Just to be on the safer side, right? A equals counter ABC. What does A show? Yeah, it does work. So if Z is in counter, we're gonna say, what are we going to say? No, I think this is just going to be a string. It will be easier to do it this way. We're going to say res str. Just call it res. It's fine. So I'm going to say res plus equal to 0 times counter Z, right? And then what we're going to do is, because Z is unique, so I'm going to say del counter Z. Actually, what I'm going to do first is let me think. No. We'll just say counter. Let's use a count. So C equals counter. I don't even need to do that. I just say C equals counter dot get Z, and then just counter Z because it's gonna give me 0 if it's, yeah, and then I think because of the counter, so if I say A minus equal, let's say 10, and then, oh no, it does go to minus. So do we say let's go to -9? Huh. What is the, hold on, so it's A minus, nah, isn't that too complicated? Yeah, that's too complicated. No. We'll just do this counter dot get Z 0. Actually, we don't have to because it's a counter. So if we try to access something that doesn't exist, it will give us a 0 automatically. So we don't have to use this here. That's right. We just do Z. So C equals this, and then we say res plus equals to 0 times C. Afterwards, we say counter Z minus equal. Oh man, can you do it? Huh. I don't like how this is going. There gotta be a more efficient way. It's like order, right? We can say order equals, so this is the order we're gonna hit. We're gonna hit 0, and it's gonna be 0. Then the next one is 2. Give us 2. Next one 6. Give us 6. Next one 7. Giving us 7. Next one is 5. Give us 5. Next one is 4. Giving us 4. Next one is 3. That'll give us 3. Next one is 8. Give us 8. And then 9. Give us 9. Finally is 1. Giving us 1. Alright, so gonna be 4 word digit dig in order, right? And we say, oh, also have to have the symbol letter. Oh man, now we are having some trouble here. Okay, not too bad. So we can do this and this and this, and I'm gonna fix Z here, W. Not 2. W. This is X. Next one is S. This one is V. This one's F. This one's R. This one is H. Yeah, H. And I. I'm gonna call it O. Doesn't matter. So it's gonna be word. Sentinel. Sent. ID, label, and dig in this order, and we say basically it's this thing, right? Counter equals this label, and the rest gonna do this, and then counter. No, it's not gonna do this. It's gonna be digit times C, then counter, then for letter in word, we're going to do counter letter minus equal C. And then we're going to continue to the next, and to the next, to the next, and then when we're done, we're going to say return sort. I think you do sort a string that is going to give you, say, A equals BCD, no, BAA, BAC. If you sorted A, this gives you this, and we have to rejoin it. So it's going to be sorted, sorted the rest, right? And then we're going to say dot join it again. Okay, so run some test cases. See how we do. Now we can actually produce automatically produce a lot of test cases, but if this one works like in the get-go, then we don't want to do it. If we hit some weird error, maybe we should try 45. This one with input is an S, and then we'll change this into original digits S, and we run it. I had a wrong indentation. I indented wrong. Okay. Alright, so I pass, so we're gonna hit it. I have high confidence in this because this is a, should I say it's a brain teaser? It's more like a brain teaser. Yep, we got it. It's like a brain teaser, and then seems more like a brain teaser to me. ON. Yeah, ON is to create the counter. The counter is creating ON, and the rest is like 10, right? It doesn't really matter too much. So it's ON. Let's see how is our performance. What did you do? Download it. I pressed the wrong button. I press Alt instead of Command. Yeah, it's fairly straightforward. 48 milliseconds, and we hit a 67% ranking. Okay, not too bad. This one does not have a solution. That's fine. Well, I mean, this might be an easy one. You know, I think this might be ranked as an easy one. Take a look. It's labeled as a medium. Okay. Oh, a lot of people don't like it. Why? It's fine. I mean, it is a brain teaser, but it's fine. What is related topic? I never see. Math. This is not math. It's an IQ test. Fun fact. Alright, so they probably have better solutions. Oh, do we follow the same? And G for 8. U. I got U. I'll use it for 4. F for 5. H, I, O. That's about the same. So they go this. Okay, so C As Z, we encounter this encounter this encounter this. Oh, there's unique for each one of them? Oh yeah, there's unique. I thought, oh, mine is actually not as good. This is even better. So I found unique for these. Oh, but they have 6 or 7, so we have to do, yeah, we count 6 first, okay. 5 and 4, 3 and 8, okay. Yep. So they can do a little bit of this manipulation. So what this person did is a little bit manipulation at the end. What I did is a manipulation as we're going through, and because we're using a counter, so we can reduce the count. Okay, that's fine. Out of the box. Does that mean I am actually thinking out of the box? Huh. I don't need to upvote this one. It's basically the same idea. What about Stefan? Stefan, what did you do? Even digits all have a unique letter, while the odd digits all don't. Oh. Each one letter is also appearing in other digit order. Ah. That's interesting. What? That's very fun, yeah. Even digits do all have unique ones. Z, W. Yeah, I didn't recognize 4. I did 5 first. Alright, I did 5 first. I did 5 because I got 7, but actually I can do 4. Because 4, U is unique. We did see that 8 is unique. I'm actually looking at H. They say G. Yeah, that's true. I'm gonna give him an upvote. He is very smart. Counters. Oh, is this the... Oh yeah, I think this is the same idea. Similar idea. Anyway, I mean, there's nothing more to discuss in this. Rust solution. Oh man, pub function. I really want to get into Rust. I heard good things about them. I'm just looking at the syntax. If it's mutable, we have to say mute. Oh, what is this syntax? Flat map. Oh man, I have to go back to all that flat mapping thing. Dot collect. As U size. This minus this as U size. So 0 equals. Then. Oh, okay. So this. Okay, this is. This is to get the index, right? This is to get the index. So we get a count for each value, and we get an index minus. Okay. Yep. Well, you can understand what they're trying to do. Implementation, right? Solution. That's like a class. Public function. From string to string. Wow, it's like a mix match, a lot of different syntax. Let counts. That means it's mutable by default. Let answer equals. Oh, what is this answer? 0, 10. So it's going to be an array. Initialize with 0 with 10 values. Okay. So we're gonna have an iterator to repeat I as U8 plus this as char, and then dot take answer. Take that many, right? Take that many. So I think I think what this is from 0 to 10, right? From 0 to 10, we're gonna flat map 0 to 10, and each value is gonna be passed in as this thing I. So I is 0 to 10. No, 0 to 9, 10 not included, and then we're gonna repeat it, right, based on how many times answer I is, and what we repeat is the I. We're gonna put it as I guess it's UTF-8. Not really UTF. Yeah, maybe it's been UTF-8 or 8 size 8 unsigned integer, could be, and I plus this. Then this is the binary for this, which gives us a code like the ASCII number for the actual digit in string as char. So we're gonna repeat this thing. Which one gets taken first? I think it's a repeat. Yeah, this one would be a lazy. Yeah, this one is a lazy evaluation. Right? It's a lazy evaluation when you call repeat, and then you call it how many times you want to take it. So I'm going to take it however many times. So this one will return however many repetitions of that digits. And then once you do that, it's flat mapping it, which means it turns that just into the same shape as this. So each one of them will be converted into like a string, right? A string, 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 string. And then eventually, I think this collect means we combine all the string together. But that's my understanding of this algorithm and in Rust. Interesting. I'm going to give it a vote. I think whenever you see a Rust, maybe I'll just take a look. It's fun. All right, that's it. That's it for today. We got an easy one. It's labeled as medium, but I mean, honestly, this is just a brain teaser. It's pretty simple. 423. All right, that's it for today. I will see you guys tomorrow. Adios.